This video focuses on the calculation of means for our scale questions, in addition to running the ANOVA test, which is looking at the mean on a scale question as compared to a nominal or a categorical variable such as gender or ethnicity, to determine if the categorical groups have statistically different scores on the mean of that particular scale question. So that's the topic that we'll be studying. Now, with running a calculation of means as a basic test, we first start, like with frequencies, we look to analyze. In this case, we go down to the label for descriptive statistics and then select the option for descriptives. Once we do that, remember we have our dialog box from SPSS where they're asking for more information or more details regarding what mean they should be calculating. And here I like to run means for scale questions. So for example, the have you been to a movie in the past year question is a yes or no, so I will skip that one. However, importance of movies was a scale question, so we could look at that. Snack bar purchases as well. So we could look at a couple of mean scores on some important variables. Let's run this test first just to see what it looks like. So you select your variables and push them over and then say OK. And then this is what we'll get in our output table. So the descriptives tables are pretty straightforward. You see on the far left the labels of the variables or the questions from our survey that we've looked for. We looked at the importance of the movies and snack bar purchases. The N column tells us how many people completed that particular question on our survey. There's a minimum and a maximum column, which will tell you the minimum score and the maximum score. And as you see, as you remember from the survey, it's a 1 to 4 scale, so that makes sense that there are some 1s and 4s. And then we get here the third column that we're most intrigued about running this test is the mean. And we see that for our sample, the importance of movies on the 1 to 4 scale, the overall mean was 2.25. Now at this point you'll need to look back at the survey to determine which direction the scale was using. Does 1 mean that it's very important or very unimportant, and likewise 4. So understanding which direction the scale is, or the anchors are, is important to reflect on. The snack bar purchases, the mean score is 1.94, and remember that was asking people how likely or unlikely they are to buy items at the snack bar. So when we run these descriptive statistics, what I like to do is typically, and here I'll do this again, analyze with descriptive statistics and descriptives. What I like to do, let me push these two variables back over to the rest of the set. I like to typically run a group of variables together that seem to make some sort of sense. Now if you remember from the survey, we had a variety of importance questions asking people about what's important to them when they're selecting a movie theater, and I've selected all of those here to run a set of means to see what they look like together. So here all of the importance variables or traits of a movie theater are listed, again with the N and the minimum and the maximum, but now I can scan through to see, in a sense, which of these factors or traits of a movie theater appears to be most important. And remember, this was a scale of 1 to 4 from not important to very important. And so I would be looking for the highest average to give me some insights that this 3.66 appears to be the variable or linked with the importance being comfortable chairs as one of the most important factors people look for when they consider a movie theater selection or choice. You see the sound system has a pretty high average as well of 3.57. So if a couple of them are in the high 3s, the lowest by far is the importance of the arcade, a mean score of 1.22, indicating this one is something that's not that critical when people are considering selecting a movie theater. So this kind of analysis helps you understand the mean scores on some of your scale questions. Interesting to look at, but for most of our hypotheses on the project, we're looking into more details of running an ANOVA where we look at one of these individual means and, for example, comparing exploring how do men and women compare on the importance of auditorium seating. Do men find that more or less important than women or not? And most of the groups have some hypotheses specifically relating to that type of test. So let's talk a little bit about how to run an ANOVA. First of all, I'll clean up all the output tables because I don't want those here. So what I do is I go to Edit and select all. I simply say delete, and those tables will be removed from my output. So now when I run my ANOVAs, I'll have a fresh set of information. To run an ANOVA, I start with Analyze. This time I select Compare Means, and then I select the option of Means. Here's where in this dialog box I need to clarify for SPSS what I'd like to do with the ANOVA test. First of all, we take the variable that we're interested, that's the continuous scale question, and we put that in the dependent list. So as an example, let's do the one we did in class. Let's look at how physically and socially active people are. So we'll start off with physically active. That's the variable. That's a 1 to 4 scale, question 9. And then let's also look at men and women and see if there's a difference between men and women on that physically active variable. So we move the variable that's the nominal or the categorical variable, the one that we're splitting into two groups, down here in the independent list. So essentially what we're doing is we're looking at the physical activity levels by men and women to see if there's a difference between the two of them. One other thing before we select OK here on our test is we need to click this options button in order to make sure we get the right output. We need to select this ANOVA table and ADA, make sure that's highlighted. You typically just need to do that the very first time you run an ANOVA, and it'll save that for the rest of the ANOVAs you run during this session. Once you do that, you say OK, and then we can look at the output tables and talk a little bit about what we're looking for. The first table, case processing summary, is not much of anything you need to worry too much about. However, this report table, the second one down, shows you that for the physically active variable, we look at gender, male and female, and then total, and you see the means here. The mean for males on this particular physically active question is 3.44. For females, it's 3.04, and you can see that the overall average was 3.22. The question becomes, although it appears that males have a higher level of physical activity, 3.44 to 3.04, the question, as you know, becomes, is that statistically significant difference between males and females? That's where we look down at this ANOVA table, the third one that's presented for us here in SPSS. So as we look, we can see that we're testing physically active by gender, and what we look for is the significance, or the p-values we've talked about in class, and that's over here at the far end of this table, labeled SIG. It's an abbreviation for significance. This is the p-value for this test, 0.000, and that tells us whether or not this test is significant. Now, if you remember from our discussions of the p-values, this was from our class where our p-value decision rule that we're using is 0.10. So if the p-value is less than 0.10, we have a statistically significant difference, and if it's higher than 0.10, there's no statistically significant difference. Now, as you can see from this output table, the significance of 0.000, clearly below 0.10, so we have a statistically significant difference. So what I would conclude from this test is I can say with confidence that the males have a statistically higher physical activity level than females do, and you can make your inferences and discussion based upon that. So what we found here is a statistically significant test done through our ANOVA testing. Okay, let's try one more just to make sure you get the example and see how it worked. Let's go back to Analyze, Compare Means, and Means. Now let's explore still by gender, but let's not look at physical activity level, and let's look at socially active. So we grab question 10 and push it up to the dependent list. If you go back to the options button, you'll see that tab is already highlighted for us, so we can just say continue. And then when you say OK, you're going to get your output tables for the socially active variable. And what you see here is that, again, we have the report of socially active with males and females. You see the differences are a little bit closer together, socially active by gender. Notice over here the significance, or the p-value, 0.094, very, very close to 0.10, but by our decision rule of 0.10, still statistically significant. If that were higher than 0.10, we would conclude that it's not statistically significant. I would actually call this marginally significant, since it is so close to that 0.10 cutoff. So that's how we can test to determine if there are significant differences across groups that we're interested in. You could do this for males or females. You could do this for any other categorical variable where people are broken into groups, and you can explore how those groups have differences across their means. So that's the test for ANOVA. You've got a homework assignment related to ANOVAs where you can practice a little bit more and test for yourself these outputs and see what the conclusions might be. Let me know in class if you have any questions or need help on ANOVAs or running means.